There is a planet drifting through the dark right now, roughly 620 light-years from Earth, with no sun above it, no star in its sky, no warmth from outside to keep it from freezing. It has never had a sunrise. It has never had a day. It exists in permanent, absolute darkness, in temperatures cold enough to freeze every gas in our atmosphere solid. And as of last year, it is eating, not slowly, not gently. 6 billion tons of material per second is falling onto its surface, being pulled in by magnetic fields so powerful they funnel gas and dust down to the planet's skin, heating it into a glowing hotspot that burns against the surrounding dark like a wound that won't close. The most powerful planetary growth rate ever recorded, happening on a world that has no business existing at all. James Webb found it. And what Webb found when it looked at this place, along with dozens of others like it discovered in the past 2 years, has shattered one of the most fundamental assumptions in planetary science. The assumption that planets form around stars. The assumption that a world without a sun is just a cold, dead rock in the dark. That assumption is wrong, and what replaces it is far stranger. To understand why this changes everything, you have to understand what we thought we knew. For most of modern astronomy, the story of how planets form was considered mostly settled. A young star collapses from a cloud of gas and dust. The leftover material doesn't fall into the star. It flattens into a spinning disk, a protoplanetary disk, like a slow whirlpool of debris circling a drain. Over millions of years, dust grains in that disk collide and stick together. Small pebbles become boulders. Boulders become planetesimals. Planetesimals slam into each other and become planets. The process takes time and chaos, but the star is always at the center of it. The star is the anchor. Without a star, the story doesn't start. That was the model. Solid, tested, taught in textbooks. The problem is that the universe ignored it. In 2023, the James Webb Space Telescope pointed at the Orion Nebula, the most famous star-forming region in the sky, the fuzzy smear below Orion's belt that you can just barely see with the naked eye on a clear night. Webb's infrared eye, able to see heat and light invisible to any human instrument before it, swept through that nursery of newborn stars and found something that didn't fit. Pairs of objects, drifting together through space, Jupiter-sized, warm enough to glow in the infrared, and orbiting nothing, not a star, not a brown dwarf, each other weakly through empty space. Scientists called them jumbos, Jupiter mass binary objects, and the immediate question they raised was simple and deeply uncomfortable. How did they get there? They couldn't have formed around a star and been ejected, because ejected planets don't come in matched pairs. They couldn't be brown dwarfs because they were too small. They seemed to have formed the way stars form, from a collapsing cloud of gas, but with nowhere near enough mass to ignite. Failed stars, stillborn suns, worlds that almost became something and ended up as nothing. But here is what made astronomers lean back in their chairs. If these objects formed like stars, then the rules for what makes a planet are not what we thought. And if the rules are not what we thought, then the number of planets in the galaxy is not what we thought, by a very large margin. Before Webb, the best estimates for the number of rogue planets, free-floating worlds with no star, range from billions to hundreds of billions in the Milky Way alone. Those estimates came from gravitational microlensing events, moments when a passing rogue planet bends the light of a distant background star by the tiniest fraction, creating a brief spike in brightness that lasts for hours or days before fading. By counting those spikes, astronomers built rough population estimates. The numbers were already staggering. Then Webb arrived, and it could see these objects directly, not through a light-bending trick, through their own heat. Rogue planets glow in the infrared, not because they have suns warming them from outside, but because they haven't fully cooled from their own formation. The collapse that made them generated heat, and that heat bleeds away slowly over millions and billions of years. A young rogue planet, a few million years old, can radiate enough warmth that Webb's instruments can see it directly across hundreds of light years. An old one, billions of years into its existence, has cooled to something close to absolute zero, cold enough that Webb struggles to find it at all. That gap between young and old is part of what makes this so unsettling, because for every young rogue planet Webb can see, There are an unknown number of old ones it cannot. Dark worlds, cooled down to ambient temperature, indistinguishable from empty space to any instrument we currently possess, moving through the galaxy in complete invisibility, each one the size of Jupiter or larger, carrying no light and emitting no heat, crossing distances between stars over millions of years without anyone ever knowing they were there. The current scientific consensus is that there may be more rogue planets than there are stars in the Milky Way. Some estimates place the number in the trillions. Let that number sit for a moment. The Milky Way contains somewhere between 100 and 400 billion stars. The number of rogue planets drifting through it, visible and invisible, may exceed that by a factor of 10. The galaxy, in other words, is largely made of planets. Planets with no suns. Planets with no names. Planets that have been drifting through the dark since before Earth existed and will still be drifting long after the sun burns out. But the jumbos were just the beginning of what Webb found. In 2024, between August and October, astronomers used Webb to study 8 free-floating planets in a star-forming region. They were looking for something specific, and they found it. Surrounding 6 of those 8 rogue worlds were disks. Warm, structured disks of gas and dust extending outward from the planet's surface. The kind of disks that normally only form around stars. The kind of disks from which other planets are born. Read that again. Around planets, not around stars, around planets. The disks contained something even more significant. Silicate grains, tiny mineral particles already showing signs of growing, crystallizing, clumping together into larger structures. The first stage of planetary formation, the first step on the road from dust to rock to world. These lone planets, drifting through space with no star to warm them, are in the process of building their own systems around themselves. Mini-solar systems, starless solar systems, systems of planets orbiting planets in the dark with no central sun, powered by nothing but the residual warmth of formation and whatever internal heat the central body still holds. Nobody had predicted this, not clearly, not in these numbers. The paper's lead author said it plainly. The formation of planetary systems is not exclusive to stars. It may work around lonely starless worlds too. The implication hits you slowly and then all at once. Every assumption about where planets come from, what they need to exist, what keeps them warm, what gives them chemistry, what gives them anything. All of it was built on the one example we know well, our solar system. 1 star, 8 planets, a set of moons, a belt of debris, the template for everything. That template was never the only option. It was just the only one we could see. Now return to the planet that is eating. Officially designated Char 1107-7626, it sits about 620 light-years from Earth in a star-forming region called the Chamaeleon 1 cloud. It has somewhere between 5 and 10 times the mass of Jupiter, making it among the heavier class of rogue worlds. It is young, only a few million years old, a newborn by the standards of a universe that is 13.8 billion years old, and it is surrounded by a disk of gas and dust that it has been slowly consuming since it formed. Astronomers first noticed it years ago and watched it steadily accreting material from the disk at a low, constant rate, unremarkable by the standards of young objects, a planet eating slowly, cooling gradually, following what seemed like a predictable path. Then in June 2025, something changed. The accretion rate surged, not by a few percent, not by a modest factor, by a factor of 8. By August, the planet was pulling in 6 billion tons of material per second. 6 billion tons every second. The infalling gas crashed onto the surface and superheated it, creating a bright hot spot glowing intensely against the surrounding disk. The X-shooter spectrograph on the Very Large Telescope in Chile caught the fingerprint of infalling gas in the spectrum. Webb's own instruments confirmed it. The team published the results in the astrophysical journal Letters and described it as the strongest accretion episode ever recorded for any planetary mass object. And the burst was still ongoing when the observing campaign ended at the end of August. They don't know when it stopped or if it stopped, what caused it. The leading hypothesis is magnetic fields, strong ones threading through the disk, funneling material down toward the planet along field lines rather than letting it drift in uniformly. Something only ever seen before in young stars, not in planets. The line between what a planet is and what a star is, already blurry at the scale of brown dwarfs, just got blurrier still. The scientist who led the study said something worth sitting with. He said people tend to think of planets as quiet, stable worlds. This discovery, he said, shows that planetary mass objects floating freely in space can be exciting places. That is a scientist's careful language for something the data makes viscerally clear. Out there in the dark, in a place with no sun, with no day, with nothing we would recognize as a sky, a world is feeding, growing, building itself, behaving in a way that crosses the boundary between planet and star and dares anyone to define the difference. Here is what it would look like to be on the surface of a rogue planet. Not Char 1107-7626 specifically. That one is too young and hot and actively catastrophic, but an older one, a rogue world the age of Earth, long since cooled, drifting through the space between stars. There is no sun. There is no glow on any horizon. The sky above is pure, absolute black, darker than any sky on Earth, even the darkest desert midnight, because there is no star close enough to provide even a faint smear of light. The stars visible are the same stars visible from Earth, roughly, but there are no planets in the sky, no moon, no familiar wanderers, just stars, motionless, in a sky that never changes and never brightens. The temperature depends on the planet's age, its size, and what's inside it. A young, large, rogue world still holds residual formation heat. A rocky world the size of Earth, billions of years old, has radiated most of that heat away. Surface temperatures can drop to within a few degrees of absolute zero, the coldest temperature physically possible, somewhere around minus 454 degrees Fahrenheit. At those temperatures, every gas in our atmosphere has long since frozen solid. The nitrogen that makes up 78% of our air lies as a flat, powdery frost across the ground. The oxygen is frozen, the carbon dioxide is frozen. Everything that makes air into air is lying on the surface as ice. There is nothing to breathe, nothing to see, nothing moving. But deep below the surface, possibly if the planet is rocky and large enough, there might be water, not frozen, liquid, kept above freezing by the slow radioactive decay of heavy elements in the planet's core. The same process that keeps Earth's interior molten, just at a much smaller scale. The same process thought to maintain oceans beneath the ice shells of Europa and Enceladus in our own solar system, just without the tidal push from a nearby giant. No light reaches that water. No chemistry from outside can drive it. It sits in total darkness, under enormous pressure, with a heat source that will last for billions of years. Whether anything lives there is a question that cannot currently be answered. Whether the conditions exist for something to live there, that is a question the science is beginning to take seriously. The question of life on rogue planets was considered fringe for a long time. Serious scientists mentioned it carefully, if at all. The conventional logic was clear. Without a star, there is no energy source. Without energy, there is no chemistry. Without chemistry, there is no life. The argument seemed watertight. Then two things happened. The first was a gradual shift in how biologists and astrobiologists think about where life comes from. On Earth, the discovery of hydrothermal vent ecosystems in the deep ocean, communities of organisms living around volcanic vents in total darkness, deriving energy from chemical reactions between hot water and rock rather than from sunlight, proved that photosynthesis is not the only path. Life does not need a star. It needs energy and chemistry and liquid water. Two of those three can exist on a rogue planet. Whether the third can too depends on the interior of the world, not its relationship to any star. The second thing was the rogue moon research, published in February 2026. A team at Ludwig Maximilian University of Munich modeled what happens to moons orbiting rogue planets. Moons whose orbits were stretched into elongated ellipses by the gravitational chaos of the ejection event. Those elliptical orbits create tidal heating, the same process that keeps Io volcanic and Europa liquid. The models showed that a moon orbiting a rogue planet could maintain liquid water on its surface for up to 4.3 billion years with no starlight at all. long enough for complex life to have theoretically emerged. Life without a sun, not as speculation, as a physical result of orbital mechanics. The lead researcher wrote, "The cradle of life does not necessarily require a sun." That sentence had no place in mainstream science 20 years ago. Today, it sits in a peer-reviewed paper in a major astronomy journal, written by researchers who worked the math and stood behind it. And here is the part of this story that is hardest to hold in your mind without feeling it shift something. The galaxy is full of these worlds. Trillions of them, by the best estimates. Many of them old enough that they have had billions of years for whatever chemistry or biology their interiors permit to develop. They pass through the space between stars constantly, crossing the distances between solar systems on timescales of millions of years, invisible to every instrument we currently operate. Some of them, statistically, pass through our own solar system, not close to Earth, not in any catastrophic way, but through the outer reaches, the Oort cloud, the scattered disk, silently, in the dark, observed by nothing. One may be passing through right now, a world the size of Jupiter, a few degrees above absolute zero, drifting without a sound at 0.5 kilometer per second through the emptiness beyond Neptune, 1 billion miles from the nearest planet, carrying inside it whatever chemistry it built over the last 4 billion years, since it was flung from whatever star made it and decided it wasn't needed. We have no way to know. We have no instrument pointed at that region. If it passed within a few light hours of Earth, Webb couldn't see it. It would be too old and cold to glow. It would simply be dark matter in the most literal sense, mass without light, a world without a witness. That invisibility is what makes the recent discoveries land so heavily. Webb can only see the young ones, the ones still warm enough to glow. They are the visible fraction of a population that extends, dark and unreachable, through the entire volume of the galaxy. Every one Webb finds is a proxy for hundreds or thousands it cannot. The debate about what rogue planets actually are, whether they are failed stars, ejected planets, or something new, has sharpened significantly since Webb started finding them. And the answer appears to be all three. Some form in isolation like stars, collapsing from gas clouds too small to ignite fusion. Some begin life in stellar systems and get thrown out during the gravitational chaos of early planetary formation. And some, the data now suggests, may do something more unsettling still. Some of them build new systems. The disks Webb found around rogue planets in 2024 are not passive remnants. They contain the first stages of solid formation. Given enough time, millions of years, the silicate grains in those disks could grow into rocks. The rocks could grow into planetesimals. The planetesimals could grow into small worlds, orbiting a planet that orbits nothing, in a miniature system with no star at its center, a pocket solar system, dark, wandering, self-contained. Nothing in the rules of physics prevents this from happening. The physics of disk formation and planetesimal growth does not require a star. It requires mass, rotation, and time. All three exist. Whether these miniature systems ever complete, whether the planetesimals make it to full planetary mass before the disk dissipates, is unknown. The observations exist, the models are still being built, but the discovery that the building blocks are there, around objects that have no right to have them by the old understanding, is not a small result. It is a fundamental rewrite of how the universe organizes matter. Step back now from the specific planets and the specific numbers and the specific papers. Look at the shape of what has emerged over the last 2 years. Before Webb, the universe had a structure that felt legible. Stars were the organizing principle. Everything of interest, planets, chemistry, the possibility of life, existed in relationship to a star. The cosmos was arranged around these burning points of light, and the spaces between them were emptiness, cold, empty, uninhabited dark between the warm, bright, interesting places. That picture is being taken apart, observation by observation. The spaces between stars are not empty. They are full of worlds, some warm, some cold, some still growing, some possibly harboring under their ice, the quiet conditions that life uses when starlight isn't available. The dark is not the absence of interesting things. It is where most of the mass in the galaxy lives. The universe did not arrange itself for our convenience. It did not build one type of solar system and repeat it across 400 billion stars. It built every variation it could with the physics it had, and it spread those variations across a volume of space so large that our entire history as a species, every observation we have ever made, every civilization, every instrument pointed at the sky, has been looking at the thin, bright skin of a galaxy that is mostly made of things we cannot see. Webb is the first instrument sensitive enough to start showing us that skin's inner surface. There is one more thing, and it is the part of this that stays. Char 1107-7626 is 620 light-years away. The burst Webb and the VLT observed in August 2025, the 6 billion tons per second feeding frenzy, the glowing hotspot on the surface of a world with no sun. That event did not happen in August 2025. Light takes time to travel, 620 years of time. The burst we watched happened in roughly 1405, when the Ottoman Empire was consolidating power, when Henry V was not yet King of England, when the printing press had not yet been invented, and most of Europe had never heard of a continent across the Western Ocean. The light left that growing planet 6 centuries ago and spent all of human modernity crossing the distance between there and here. It arrived at our telescopes last year. We called it a discovery. The planet, meanwhile, has been doing whatever it does for 6 more centuries since. We don't know what it has become in the time it took its own light to reach us. We don't know whether the burst ended or intensified. We don't know whether the disk survived or dispersed. We are, in the most literal sense, looking at the past and calling it news. And somewhere out there, right now, in the actual present moment, not the past we observe but the present we cannot, a planet with no sun is doing something, growing or cooling or carrying inside it something that might, given long enough, become something we'd recognize as life, drifting through the dark between the stars, alone in the most complete sense that word can mean, moving through a universe that does not care whether it is observed. James Webb found it, and what it found is not just a planet, it is proof that the darkness between stars is not empty. It is inhabited by worlds we cannot see, doing things we cannot yet measure, on timescales that make our entire recorded history feel like the blink of an eye. The universe has been building things in the dark since long before we arrived, and it will keep building long after we're gone. The only thing we can say for certain is that we have barely started looking, and every time we point a new instrument at the places we called empty, they turn out to be full. What is out there that we still can't see? We have a feeling we won't like the answer.